The abacus, often referred to as the first computing device, has a rich history dating back thousands of years. Originating in ancient Mesopotamia around 2700 to 2300 BCE, the abacus was used by various civilizations such as the Sumerians, Egyptians, Greeks, Romans, and Chinese. The earliest form of the abacus consisted of a flat surface with pebbles or beads that could be moved around to perform basic arithmetic operations. Over time, different versions of the abacus were developed, each with its unique design and functionality. For example, the Chinese abacus, also known as the suanpan, featured multiple rods with beads that could be manipulated to represent different numbers. The abacus played a crucial role in trade, commerce, and mathematical calculations in ancient societies. Its simplicity and efficiency made it a valuable tool for merchants, scholars, and astronomers. Despite the advancements in technology, the abacus continued to be used in various parts of the world well into the modern era. Even today, the abacus is still taught and used in some educational systems to help students understand mathematical concepts and improve mental calculation skills. The enduring legacy of the abacus serves as a testament to the ingenuity and innovation of early civilizations in developing tools for computation and problem-solving. The invention of mechanical calculators marked a significant milestone in the history of computer technology, revolutionizing the way mathematical calculations were performed. One of the earliest mechanical calculators was the Pascaline, invented by the French mathematician and philosopher Blaise Pascal in 1642. The Pascaline was a hand-cranked device that could perform addition and subtraction through a series of gears and wheels. It was designed to help Pascal's father, who was a tax collector, with his tedious calculations. The Pascaline paved the way for other inventors to explore the possibilities of mechanical computation. In 1673, the German mathematician and philosopher Gottfried Wilhelm Leibniz developed the stepped reckoner, a more advanced calculator capable of multiplication and division. The stepped reckoner utilized a stepped drum mechanism to automate the process of arithmetic operations. Despite their innovative designs, mechanical calculators were complex and expensive, limiting their widespread adoption. However, they laid the foundation for future developments in computing technology. One of the most famous mechanical calculators is the difference engine, conceived by the English mathematician and inventor Charles Babbage in the early 19th century. Babbage's ambitious design aimed to create a machine capable of performing complex mathematical calculations automatically. Although the full-scale version of the difference engine was never completed during Babbage's lifetime, his work inspired generations of engineers and scientists to explore the possibilities of automated computation. Another notable figure in the history of mechanical calculators is Hermann Hollerith, who invented the tabulating machine in the late 19th century. Hollerith's machine used punched cards to store and process data, revolutionizing the field of data processing and laying the groundwork for modern computing. The invention of mechanical calculators not only improved the efficiency of mathematical calculations, but also sparked a wave of innovation that would eventually lead to the development of electronic computers. These early devices set the stage for the digital revolution that would transform the world in the centuries to come. The emergence of electronic computers marked a pivotal moment in the history of technology, paving the way for the digital age we live in today. The transition from mechanical to electronic computing brought about unprecedented speed, accuracy, and versatility in data processing. One of the earliest electronic computers was the ENIAC, Electronic Numerical Integrator and Computer, developed by John Mauchly and J. Presper Eckert at the University of Pennsylvania in the early 1940s. ENIAC was a massive machine that filled an entire room and consisted of over 17,000 vacuum tubes. Despite its size and complexity, ENIAC was capable of performing calculations thousands of times faster than any previous mechanical calculator. Its ability to solve complex mathematical problems with remarkable speed made it a groundbreaking achievement in the field of computing. Another significant development in electronic computing was the invention of the transistor in 1947 by John Bardeen, Walter Brattain, and William Shockley at Bell Laboratories. The transistor replaced bulky and unreliable vacuum tubes with smaller, more efficient components, leading to the miniaturization of electronic devices. This breakthrough laid the foundation for the development of smaller, faster, and more reliable computers. The introduction of transistors also paved the way for the creation of integrated circuits, which revolutionized the electronics industry by enabling multiple electronic components to be fabricated on a single semiconductor chip. The first commercially available integrated circuit computer, the IBM 360, was introduced in 1964 and became a cornerstone of modern computing. The IBM 360 offered a range of models with varying processing speeds and memory capacities, making it a versatile and widely adopted system for businesses and institutions. The emergence of electronic computers also saw the rise of programming languages that allowed users to interact with computers in a more intuitive and efficient manner. One of the most influential programming languages of this era was COBOL, Common Business-Oriented Language, developed in the late 1950s for business data processing. COBOL's English-like syntax made it accessible to a wide range of users and contributed to the widespread adoption of electronic computing in commercial applications. As electronic computers became more powerful and accessible, their impact extended beyond scientific and business applications to influence various aspects of society. The development of computer networks in the 1960s laid the groundwork for the Internet, connecting computers around the world and enabling the exchange of information on a global scale. The emergence of electronic computers not only transformed the way we process data, but also revolutionized communication, commerce, and entertainment. The rapid advancements in electronic computing continue to shape our world, driving innovation and progress in virtually every field of human endeavor. The development of transistors and integrated circuits revolutionized the field of electronics, leading to smaller, faster, and more reliable devices. Transistors, invented in 1947 at Bell Laboratories, replaced bulky vacuum tubes with smaller, more efficient components. These solid-state devices could amplify and switch electronic signals, enabling the miniaturization of electronic circuits. The first transistor was made of germanium, but silicon soon became the preferred material due to its abundance and better performance. Transistors played a crucial role in the advancement of electronic technology, making devices more energy efficient and cost-effective. One of the key figures in the development of transistors was William Shockley, who shared the Nobel Prize in Physics in 1956 for his work on semiconductors and the transistor effect. The invention of the transistor paved the way for the creation of integrated circuits, ICs, in the late 1950s. Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductor independently developed the first integrated circuits, which combined multiple electronic components on a single semiconductor substrate. Kilby's invention of the monolithic integrated circuit in 1958 and Noyce's development of the planar integrated circuit in 1959 revolutionized the electronics industry. Integrated circuits offered higher performance, lower power consumption, and reduced size compared to discrete electronic components. The introduction of ICs led to the mass production of electronic devices such as calculators, computers, and communication systems. The microprocessor, a complete central processing unit, CPU, on a single chip, was a significant milestone in IC development. In 1971, Intel introduced the first commercially available microprocessor, the Intel 4004, which powered early handheld calculators and other devices. The rapid evolution of integrated circuits fueled the growth of the semiconductor industry and enabled the development of increasingly sophisticated electronic systems. Today, integrated circuits are ubiquitous in modern technology, powering everything from smartphones and laptops to medical devices and automotive systems. The rise of personal computers in the late 20th century transformed the way individuals interacted with technology, paving the way for the digital revolution that continues to shape our world today. One of the key milestones in the development of personal computers was the introduction of the Altair 888 in 1975. Created by Micro-Instrumentation and Telemetry Systems, MITS, the Altair 888 was one of the first commercially successful microcomputers, sparking interest among hobbyists and enthusiasts. The Altair 888 featured an Intel 8800 microprocessor and was sold as a build-it-yourself kit through popular electronics magazines. The release of the Altair 888 inspired a new wave of innovation in the computing industry, leading to the founding of companies such as Microsoft by Bill Gates and Paul Allen. In 1977, Apple Computer, founded by Steve Jobs and Steve Wozniak, introduced the Apple II, a pre-assembled personal computer that helped popularize the concept of home computing. The Apple II featured a color display, built-in basic programming language, and expandable memory, making it a versatile platform for both education and entertainment. The success of the Apple II solidified Apple's position as a leading manufacturer of personal computers and set the stage for future innovations in the industry. The early 80s saw the emergence of IBM's first personal computer, the IBM Personal Computer, IBM PC, which set a standard for compatibility and open architecture in the PC market. The IBM PC's use of off-the-shelf components and the MS-DOS operating system made it a popular choice for businesses and consumers alike. The widespread adoption of personal computers in homes, schools, and workplaces democratized access to computing power and information, fueling the growth of the software industry and the Internet. The rise of personal computers not only revolutionized how we work, communicate, and entertain ourselves, but also laid the foundation for the interconnected digital world we live in today. The era of smartphones and tablets has revolutionized the way we communicate, work, and access information. Smartphones, with their compact size and powerful capabilities, have become an essential part of modern life. The introduction of the iPhone by Apple in 2007 marked a turning point in mobile technology, combining a phone, music player, and internet communicator into a single device. The App Store, launched alongside the iPhone, provided a platform for developers to create a wide range of applications that could be downloaded and installed on the device. This ecosystem of apps transformed smartphones into versatile tools for productivity, entertainment, and social interaction. Smartphones also introduced touchscreens as the primary method of interaction, replacing physical keyboards and styluses. The intuitive nature of touch interfaces made smartphones more accessible to a broader audience. Tablets, such as the iPad introduced by Apple in 2010, expanded on the concept of smartphones by offering larger screens and more immersive experiences. Tablets bridged the gap between smartphones and traditional computers, providing a portable yet powerful computing platform for tasks like browsing the web, watching videos, and reading ebooks. The rise of smartphones and tablets has led to a mobile-first approach in technology, with many services and applications optimized for mobile devices. The convenience and portability of smartphones and tablets have transformed industries such as healthcare, education, and entertainment. With advancements in hardware and software, smartphones and tablets continue to push the boundaries of what is possible in the digital age. Quantum computers have the potential to revolutionize the field of computing by leveraging the principles of quantum mechanics to perform calculations at speeds far beyond the capabilities of classical computers. Unlike classical computers that use words to represent information as either 0 or 1, quantum computers use quantum bits or qubits, which can exist in multiple states simultaneously due to superposition. This property allows quantum computers to process a vast amount of data in parallel, leading to exponential speedups for certain types of problems. Another key concept in quantum computing is entanglement, where the state of one qubit is dependent on the state of another, even when separated by large distances. This phenomenon enables quantum computers to perform complex calculations that would be infeasible for classical computers. Quantum computers have the potential to revolutionize fields such as cryptography, drug discovery, optimization, and artificial intelligence. For example, quantum computers could break current encryption methods by quickly factoring large numbers, posing both a threat and an opportunity for cybersecurity. In the realm of drug discovery, quantum computers could simulate molecular interactions with unprecedented accuracy, leading to the development of new drugs and materials. Despite their immense potential, quantum computers are still in the early stages of development, facing challenges such as error correction, scalability, and decoherence. Researchers and companies around the world are actively working to overcome these hurdles and unlock the full potential of quantum computing. The history of computer technology development has been a journey of innovation and progress, from the humble abacus to the potential of quantum computers. Each milestone, from mechanical calculators to integrated circuits, has paved the way for the digital age we live in today. The era of smartphones and tablets has transformed how we interact with technology, making computing more accessible and versatile. Looking ahead, the potential of quantum computers holds promise for solving complex problems in cryptography, drug discovery, and artificial intelligence. While challenges remain, researchers are actively working to overcome these obstacles and unlock the full capabilities of quantum computing. The future of computer technology is bright, with continued advancements shaping our world in ways we have yet to imagine.